Hello, hello, and welcome back to Boxers Shorts, where we take difficult ideas from science and try and break them down and give you some work to do on them. Today we are going to be finishing our section to do with kind of big picture historical changes to the Earth's atmosphere. There are, of course, changes that have happened more recently that we'll get to in the next lesson, but these are, the changes that happened recently are small compared to the massive, massive changes that have occurred over the last, few billion years. What we're going to do today, we're going to round that out by looking at oxygen and nitrogen, and then we are going to do some more practice and kind of tie it all together with some longer extended response questions. Okay, so let's start with oxygen. So in the last couple of lessons, we've looked at a simple diagram that has something like this. No, that should be blue. There we go, that's better. And by the way, you can see I put these lines in today. That's because I've realized my handwriting is so absolutely dreadful without them. So this is a desperate bid to make my handwriting a little bit better. What were those green things, please? Can you say the name of those green things on 3? 1, 2, 3. Yep, that's algae. Algae pull a gas out of the atmosphere. What was the name of the gas that the algae pull out of the atmosphere? Say your answer on 3. 1, 2, 3. I'm hoping you said carbon dioxide. They pull carbon dioxide out of the atmosphere. In what process? What process do they pull carbon dioxide out of the atmosphere in? Say your answer on 3. 1, 2, 3. I'm hoping you said photosynthesis. Now, in turn, there's a gas that they pump back into the atmosphere. What is the name of that gas? Say your answer on 3. 1, 2, 3. I'm hoping you said O2 or oxygen. Now, why is all this important? Because as we spoke about last lesson, the amount of carbon dioxide in the atmosphere then over time starts to fall. It starts to go down, and the amount of oxygen in the atmosphere starts to go up. Why does this matter? Well, in the Earth's early atmosphere, there was basically no oxygen at all. In Earth's atmosphere now, about 20% of Earth's atmosphere is now oxygen. And that comes from algae and it comes from plants doing photosynthesis. That's really useful for us. Why is it really useful for us if there's oxygen in the atmosphere? What do we need oxygen for? What process do we need oxygen for? We looked at this in the very first lesson together. What process do we need oxygen for? Say your answer on 3. 1, 2, 3. I'm hoping that you said respiration, not breathing. Breathing is just going like that. Respiration is what our body actually uses the oxygen for. So we really need that oxygen, and it comes from algae and it comes from plants. So over time, carbon dioxide goes down and O2 goes up, such to the extent that carbon dioxide used to be, over 90% of the atmosphere, and oxygen was basically 0, and now carbon dioxide is 0.04% thereabouts, and oxygen is now roughly 20%. The other gas we need to look at is nitrogen. Now, let's look at a diagram like this. What do you think this is a diagram showing? And I'll give you a big hint. This is roughly, this is roughly 4.6 billion years ago. What does this show? Say your answer on 3. 1, 2, 3. I'm hoping you said it shows volcanoes. Why are volcanoes relevant to our story? Say your answer on 3. Why are volcanoes relevant to our story? 1, 2, 3. I'm hoping you said because they produced the gas that made up Earth's early atmosphere. The majority of that gas was, of course, CO2. But they did produce tiny, tiny, tiny amounts of gases like nitrogen, N2, and gases like ammonia, NH3. Now, over time, NH3 in some chemical reactions can turn into N2. And there's a reason for that. Nitrogen, N2, is an incredibly stable molecule. It's very unreactive. It's not quite as unreactive as the noble gases, but it is pretty unreactive. And what that means is that anytime you produce a tiny amount of N2, it doesn't go anywhere. So let's say, this volcano produces just like one tiny bit of N2, and that's it. And then 100 years later produces, where's my pen gone? 100 years later, so that's that N2, and 100 years later produces another N2, and 100 years later produces another N2. And then 100 years later, another N2. Now, over time, these build up because they don't go anywhere. There's nothing that can react with them. They don't turn into anything else. It's not like they can magically turn into, you know, a protein in a human or whatever. They just build up and build up and build up until eventually you get more of them and more of them and more of them. And if there's a chemical reaction that produces them again, it's exactly the same. You just end up with more N2, more N2, more N2, more N2. So that in Earth's early atmosphere, there was very, 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 very little nitrogen. But in the atmosphere today, we're talking about 80% nitrogen. And the reason for that is because of how stable it is, so it builds up over time. So if we were to write those out as take homes, as we've done before, so oxygen, we would say the amount increased over time to about 20% nowadays, and it's produced, or that's because it's produced in photosynthesis, which is what we were just looking at. So you can quickly pause your screen and write this down for me. Okay, you should only be pressing play if you've written that down, and we'll write about nitrogen now. So I just want to make sure we get exactly the same phrasing when we do. Okay, so we'll write again, amount increased to about 80% nowadays. And what we'll write, it's unreactive, so builds up over time. So any process that produces nitrogen, whether it's a volcano or a chemical reaction or whatever, that adds the total amount of nitrogen, and it doesn't go anywhere because of how unreactive it is. So please write that down for me too now. Pause your screen, write that down. Okay, you should only now be listening to me if you have had a chance to write that down, and it's time to do some questions. Yay! Everybody's favorite. Okay, here we are. Questions 1, 2, 3, and 4. And for question 1 over there, I've given you the number of marks. I'm just going to kind of resize that a bit so that I can squeeze more onto your screen, so it's a bit bigger for you. No, that should do. Okay, so pause your video as ever. You know the drill by now, and answer these questions. Okay, you should only be listening to my voice now if you have answered these questions. We should get our purple pen or whatever pen you're using to write in our hands. Describe how the amount of nitrogen, oxygen, and carbon dioxide in the atmosphere has changed over time. Now, I'm just going to make the lines a bit smaller so it's easier for me to write. Will that do it? Can I make it even smaller? Yeah, I like that. Okay, let's go with that. Right, so what we'll do to answer this, so again, it's a describe question. So it's just a describe how. So we're not going to go crazy explaining each one. We're just going to say nitrogen. We're going to say oxygen, and we're going to say carbon dioxide. How has nitrogen increased? How has oxygen decreased? How has nitrogen changed? How has oxygen changed? How has carbon dioxide changed? Nitrogen has increased. Oxygen has increased. And carbon dioxide has decreased. And that's it. That's all you need to do for that question, because all it says is describe how. Next up, explain why under normal circumstances, nitrogen will not react with oxygen. And the answer to that is, as we've discussed, nitrogen is very unreactive. Done. Volcanoes can produce ammonia, which reacts to form nitrogen. Copy the equation and balance it. Now, if you've got no idea how to balance an equation, that's absolutely fine. Fortunately, I've got your back. There is a video on Boxer's Shorts about balancing equations that employs Mr. Boxer's balancing box method, and it is beautiful. It works every single time. So make sure you just go watch that video about balancing equations if you weren't sure how to do this. I'm just going to quickly do it here. Let's go there. Let's go 1.5. So let's make that. Oh no, come back. So we'll make that a 4. Make that a 6. Make that 3, we'll make that 2. Yes, so we've got 4 nitrogens here, 4 nitrogens here, 1, 2, 3, 12 hydrogens on the left, 12 hydrogens on the right, 6 oxygens on the left, 6 oxygens on the right. Bingo. Explain why this reaction could not take place until 2.7 billion years ago. Well, what is it that happens 2.7 billion years ago? Say your answers to the screen, please. What happened 2.7 billion years ago? 1, 2, 3. So that's when life originated, and it was life that produced that oxygen. So we could say that life only originated or came into being 2.7 billion years ago, and there was no oxygen or very little oxygen in the atmosphere before then. And there we go. So those questions were really more of a check for understanding than anything. And what I want you to do now is we're going to do the real meat. So these questions have all been like of the type that you might get in an exam. But what I want to do now is start like tying them together into bigger and bigger questions. So I've written out some, oh, come back here, come back, where are you going? There we are. So I've written out some questions here, and I've given you the number of marks for each one. And each one asks you to discuss a different gas from the atmosphere. And each one asks you to both describe and explain. So all I want you to do first, right, is question 1. Just do question 1. Don't do question 2, 3, and 4. Just do question 1 in your book, please. Pause the screen and just do question 1. Okay, you should by now have done question 1, and you should only be listening to my voice if you've done question 1. So it says describe and explain how the amount of oxygen in the atmosphere has changed over time. And we're going to go for 3 marks here. So the first mark we're going to get is for describing. So we're going to say the amount of oxygen has decreased. That gets us, sorry, not decreased, what we're talking about, has increased. Losing my mind. Has increased. Why? It's produced by plants and algae in photosynthesis. Now that gets us 3 marks, okay? And I really need you to make sure that you've got those 3 points, including this kind of introduction. This is the how bit. So this is the describe how. This first bit is, oh, what is that? That's left over from earlier when we were drawing water. So, okay, so this bit is describe how, and this bit is explain. Both of those points are explain. Okay, so you've got to make sure that you do both the describe how and you do the explain for each of these. Okay, so you can mark your answer there and press play when you're ready to go. All right, so we've now got questions 2, 3, and 4. Have a go at those, please. Pause the screen and do question 2, 3, and 4. Okay, you should only be listening to my voice now if you've done question 2, 3, and 4. And again, I remind you, I will take the opportunity to remind you, and I will do this every single time. These questions that I put up for you, they're not a joke. I'm not here to mess around. And like, if you're just sitting there, just watching the video and scrolling or whatever, and you're not actually doing the questions, then you're wasting your time. And I know sometimes I ask you like to say things to the screen, and I know sometimes it feels like a bit awkward, but like it's a good way to learn. So why would you not do that? Right, I've done, what we're doing, right? Ignore question 1 because obviously I had a complete brain melt over there, but I've got answers for you for question 2, 3, and 4. And I think what we'll do is I'm going to resize these. Give me a sec. I'm just going to pause the recording. Okay, sorry, I made a complete error there. I had a brain melt, like I said, but you should be able to start correcting your work now. And what I'll do is each time I'll just roll down, you can pause your video and mark your work and then move on. So there's question 1, which we've actually done already. Here's question 2, which could be 3 marks. It could be 4 marks on a good day. Here's question 3, which again could be 4 marks on a good day. And here's question 4, a nice big 6 marker. So pause until you finish marking that and press play when you're done. So you should only be listening to my voice now if you've done what you're marking. And I don't hesitate to remind you that in each of these questions, you know, when there's 6 marks, most students just say, no, forget it, I'm not going to do this one, and get a 0. But like, it's really daft because this stuff isn't difficult. And, you know, I've got 1, 2, 3, 4, 5, 6, 7, you know, I've got less than 20 words here, right? And you get 6 marks for that. It's, you know, it's a no-brainer. You know, it would be really a massive mistake just to not do it. And again, they love asking questions like this in exams. Just make sure you always do your describe and you do your explain. So this bit here is your describe and this bit here is your explain. In the next videos, we'll start looking at the number 1 issue, which is affecting global society at the moment, which is, of course, global warming and climate change. And I look forward to seeing you again soon.